Lesson 6-7 is on similarity transformation. In a previous chapter, we talked about three types of congruence transformations. What we said is that we could take a figure on a coordinate graph and simply slide it around the graph, or it's called a translation. We could take the figure and flip it over, we call that a reflection, and we could take the thing and rotate it or spin it, we call that a rotation. And so we have translations, reflections, and rotations that move the figure around on the graph but give us congruent figures. Today we want to look at a transformation that's going to keep the shape of the figure but not the size of the figure. We call this a similarity transformation because it will give us similar figures but not congruent figures. We can make a similar figure by using a scale factor to make the original figure either smaller or larger. And we call this type of transformation a dilation. To perform a dilation, all you really have to do is multiply by your scale factor. We'll call that k. So xy yields kx ky. So if I'm dealing with a point like 1, 3 and I have a scale factor k of 4, then I'll simply multiply 4 times 1 is 4 and 4 times 3 is 12. So my image is 412 from the pre-image of 1, 3. If k is bigger than 1, it's going to make that figure larger, and if k is less than 1, it's going to make it smaller. Also, you'll notice that when k is greater than 1, the figure moves away from the origin of the graph, further away, and if k is less than 1, it actually moves the image closer to the origin of the graph. So we have a dilation of a quadrilateral ABCD with vertices given here, and they want to use a scale factor of 2. So I want to draw this dilation. First I'm going to draw ABCD, then I would dilate and then get the other one. So here are my two images after taking xy and yielding 2x, 2y. The A 2, 1 becomes L 4, 2. The point B 4, 1 becomes point M 8, 2. Point C 4, negative 1 becomes N 8, negative 2. And point D 1, negative 1 becomes P 2, negative 2. Notice all I did was take all of the values, x and y values for A, B, C, and D, and multiply everything by 2. The drawing, as you can see, gives me an image that is larger than the original and further away from the origin. Let's look at a figure that works smaller because we have a scale factor of 1/2. So I have a triangle, I've got the vertices of the triangle, and I'm going to do a dilation of 1/2. What we're going to want to do is look at this and make sure that they're similar. So first I'll sketch ABC and DEF, and then I will verify that they're similar. Now to sketch them, I'm going to first do the transformation. What I'm doing is multiplying 1/2 times both x and y. So I do that with all three of the points. Then I can set these up and see that 4 over 2 does equal 6 over 3. So the lengths of the sides that include C and F are proportional. Therefore, ABC and DEF are similar by the side angle side similarity. Here's the guided practice that you can try. Find the coordinates of L, M, and N so that it is a dilation of PQR with a scale factor of K. When I do that, notice that my scale factor is 4, it's greater than 1. It's going to give me a much larger image, and it is going to be closer to the origin, further from the origin, excuse me. Also, there is a mistake in this. This is 2, 2, not 221. Sorry about that. In this one, it's got a scale factor of 0.4, so we should know that it's going to be smaller and closer to the origin. So when I make my transformations by multiplying each thing by 0.4, I get my new image that is smaller and closer.